And I like to quote Alan Hollister from Raspberry Pi. He will say, well, I expect ANML in the short to longer term to be the layer on top of the sensors to bring the smartness in the less intrusive way. And that is what I expect also in the future. I expect ANML to be the default way to bring the intelligence, to help engineers to develop smart applications without necessarily require internet connection. That is also what I expect.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Gian Marco. Gian is a tech lead in the machine learning group at ARM and the author of the Tiny ML Cookbook, published in April of 2022. At ARM, Gian looks after the ML performance optimizations for the ARM Compute Library, which he co-created in 2017 to get the best performance on ARM Cortex-A CPUs. ARM Compute Library is currently the most performant library for machine learning on ARM, and it's deployed on billions of devices worldwide, from servers to smartphones, so very impressive. Gian holds an MSc with honors in electronic engineering from the University of Pisa in Italy, and has several years of experience developing machine learning and computer vision algorithms on edge devices. In 2020, Gian co-founded the Tiny ML UK Meetup Group to encourage knowledge sharing, educate, and inspire the next generation of machine learning developers on tiny, power-efficient devices. Thanks, Gian, for being on the program today.
Yeah, thanks a lot for inviting me. Actually, it's a real pleasure to be here, Justin. Really pleasure. Thanks a lot.
Yeah, sure. Awesome. Well, I gave a little bit of an intro, during my intro on where you are today at ARM, but maybe you could fill in a little bit of the trajectory of your career and some of the work that you did, leading from university all the way up to your current role today.
Okay, definitely can start formally from when I left the university. So I graduated in hardware, in a software and hardware co-design for developing computer vision and machine learning on embedded devices. And when I joined ARM, I have been lucky enough to enter the company when actually machine learning was starting to be deployed on edge devices. And with edge devices, I mean primarily smartphones. Actually, my background was a bit different because when I entered that world, machine learning was a bit different. We primarily looking for, let's say, specific features in images like the histogram-oriented gradients. I didn't study, for instance, convolutional neural networks. Definitely something that I learned at ARM and deploying the first models on edge devices. And I remember when I joined ARM, the first year we decided to create this library for machine learning with the aim to provide the best performance for the critical operations that we have in machine learning workloads, in particular for convolutional neural networks, for Cortex-A CPUs and Mali. So definitely I have been lucky enough because I joined when ML was arriving definitely at the edge. And the problem there was how to make it faster. It wasn't the problem of deployment. We could deploy because smartphones were already powerful enough with already 4 gigs of RAM, for instance, enough memory. The only problem was performance. How we could make machine learning models running in real time on these devices? That was the big problem that we faced and we tried to address at the same time.
What was the time frame, I guess, when you were joining?
Okay, I would say the first couple of years, so 2016, we started designing the library. In 2017, we released on GitHub the first operators for convolutional neural networks. And yes, the optimization were mainly for Mali GPUs and Cortex-A CPUs, and regarding the matrix multiplication routine in particular, pooling layer. So not all the operators that we can see right now, but just a subset of those the critical ones.
I see. Now, were there both CPUs and GPUs in cell phones at all? At that time, was it just all CPUs, I'm assuming?
Yeah, so on smartphone, you have both. You can run machine learning on both on CPU and GPUs. And actually, GPUs are really powerful and not just power in terms of computation capabilities, but also power in terms of power efficiency. So they're both capable to run machine learning workloads definitely in a very efficient way. And the intent of the library was to deliver the value, right? The value in terms of performance, which also meant trying to reduce the power consumption of the device when running these workloads.
I see. And you, like you said, you're running them. I mean, ARM is sort of the de facto standard, I guess, when it comes to small devices, I guess, cell phones and whatnot, right? I mean, you guys have a huge market share in the space today, correct?
Yes, correct. I think over 90% of the smartphones are powered by an ARM CPU for sure. There are also quite a lot of Mali GPUs as well. So yes, definitely. ARM is enabling quite a lot of smartphones around us, I would say.
Very cool. It must have been fun to sort of get into such a large company like that and then be able to have such an impact, I guess, in building this library and sort of, again, be able to open source it and sort of move all of this stuff forward. So really, sort of, I guess, a testament to the culture at the company to allow you to explore and do other things, right, that actually move the open source community forward.
Well, yes. Personally, it was exciting because I left the university and I joined this group with intent to build a library for both computer vision and machine learning. And at the end became just machine learning because computer vision converged to convolutional networks at the end. But it was really exciting for me because it wasn't just an implementation. So it wasn't just implementing operators, it was also a learning curve for me as well. So learning convolutional networks, learning new techniques for optimizing operators on Cortex-A CPUs and Mali GPUs, because the goal was and actually is, because the library is still there, make the operators really efficient on ARM.
And so then this kind of leads into my next point I think we're going to talk a fair amount about here is, the book that you wrote, the TinyML Cookbook. I think when you and I had sort of talked offline, and it even says it in the book, it's really geared for sort of machine learning developers or engineers interested in developing applications on microcontrollers. So as you were getting into this space, you might have been coming at it from the other way. I'm guessing, right? You were an electronics engineer that was working on hardware and embedded work, and then really probably learned the machine learning sort of stuff along the way. Is that kind of true with regards to what came first in your career?
It was like that, exactly like that. And here probably I need to thank ARM because I have been lucky enough to work on ML from the server space to the very edge devices like microcontrollers, for example, all ARM powered. And what I brought to the company actually the background on electronic engineering and trying to optimize these routines. I mean, keep in mind the hardware capabilities, but definitely what I experienced on the machine learning side of things was a different story compared to what I have faced with, for instance, with smartphones. Because as I mentioned earlier, with smartphones, the big problem was mainly how can we make it faster? We could run it. I remember we had AlexNet, BGG16, also Inception V3. I mean, one of the first models where we could run it on smartphones. Probably not in real time, but the device it was capable to do it. Well, when microcontrollers is a completely different story.
Okay.
I mean,
tell us why.
If you don't know your hardware, well, actually, you cannot run anything on microcontrollers. That is the reason every time I say, well, TinyML, that is the reason we don't call it machine learning, we call it TinyML. It's the field of study where wants to know machine learning the embedded word at best, because if you don't know the hardware device, you will not be able to run anything on these devices because they have limited computation capabilities for sure, and also limited memory as well. If you ask me why they have these constraints, well, because are low power. Definitely, if you want low power device that you want to run on a battery, let's say for a month without charging it, well, you need to sacrifice something. And definitely, probably you don't have the same hardware capabilities that you may find on a smartphone. And at the same time, you don't have the same amount of memory that you may find on, as I said, on a smartphone.
So you saw these challenges, you started working on this, but at some point you decided to say, I'm going to create a book around this. I mean, what was your motivation for creating the TinyML Cookbook?
The motivation actually started from my background because, as I said earlier, I graduated in hardware software co-design for machine learning and computer vision. But when I was at uni, machine learning, it wasn't really that easy. You had to be an expert. You had to be an expert knowing the algorithms involved. It was difficult. Also, the data acquisition, it was a completely different story. Furthermore, also in embedded programming, it wasn't that easy at that time. It wasn't that easy because in some cases you had to use assembly to simply control, the LED, and the code that you wrote couldn't be ported to other platforms as well. That was a very big limitation. But now is completely different, the story, because machine learning is actually more accessible, I would say. It's more easier than a few years back. But embedded programming as well is a lot easier. So with few lines of code, you can turn on and off an LED. You can control external peripherals. And the motivation of the book was this. So I wanted to demonstrate how easy it is now machine learning on microcontrollers to people with no or little familiarity in embedded programming. So for this reason, the book is mainly oriented to people with machine learning background. So like ML developers, ML engineers, but also embedded engineers can benefit from the book, of course, but they need to have at least a basic understanding of machine learning. The other motivation was to help these people because I wanted to add something to the TinyML community, because that TinyML community has one brilliant book written by Pete and Dan, which is a TinyML actually. And I wanted to offer another book complementary to that one to cover the part more oriented to people with no embedded programming experience.
Yeah, that's cool. I mean, I teach a class on the Internet of Things and machine learning at a local university here in their graduate school. And it's for people that are going through a master's in software engineering program. And so they're used to coding, but they're not really used to microcontrollers and hardware. And it's been kind of fun coming at it from that angle, saying, hey, here's an Arduino, here's a breadboard, here's how you sort of plug this stuff together, because they're kind of out of their comfort zone a little bit. And at the end of the course, they really enjoy it, right? They are like, wow, I didn't think through a master's in software I'd actually get a chance to get my hands physical and get data from the physical world. And so you've kind of flipped that around. You've gone the other way, right? You sort of have people that maybe know, well, I guess maybe it is sort of similar. It's geared for machine learning developers that maybe know how to do the ML models, but they're not really deep into the applications inside microcontroller code, correct?
Yeah. And definitely now is easier. In the book, for example, use the Arduino board, the Raspberry Pi Pico. The book in particular, the reader will not install any software to build the projects because they will use the web browser, because most of the tools will be browser-based or cloud-based, actually. So no setup, simply connect the microcontroller to the laptop, and that's it. Magically, it's going to work. So it's definitely different from what I experienced at uni, for sure.
Yeah, for sure. Well, we always put sort of liner notes and links and stuff in the description of our podcast. So absolutely, we'll have links off to your book. And, as I purchased your book and I've been kind of like looking through some of the examples, looks like some of them actually use this other company called Edge Impulse for some of their stuff. And what I found interesting about Edge Impulse, correct me if I'm wrong, but, you can run a lot of stuff on your cell phone, right? It allows you to do a lot of training using essentially hardware you have in your pocket. And I'm assuming, were we trying to base a lot of these examples maybe around maybe everyday real world use case examples? In fact, maybe you can share with us some of the things that happen in the book. Like I know you do stuff around sight and sound. I don't know, were there some specific examples that you enjoyed building and creating as you did this book?
Definitely Edge Impulse is a good example of why ML became that easy, because I found it extremely straightforward to use the tool, not just for building the machine learning models, but also for doing the data acquisition from the device. Because at the end, ML, yes, is machine learning, so algorithms, but also data acquisition. You need data to build your product. Edge Impulse offers an easy way to do it from Arduino and Raspberry Pi Pico. So that is the thing I really enjoyed. In terms of projects in the book, probably chapter 5 and chapter 6, I'm going to say in a bit what they talk about. So chapter 5 is about indoor scene recognition. So the aim of the chapter is to build a machine learning model for Arduino Nano that is capable to recognize indoor environments. So in that case, Edge Impulse is not used. Only TensorFlow and TensorFlow Lite for microcontroller will be used for this kind of application. But the reason I enjoyed writing that chapter is because that chapter is not just about ML. Because most of the time we would think about, well, the big problem is building the model. Well, on microcontroller, this is part of the problem because that is also the part related to, okay, the data acquisition and how do I feed the data in the most efficient way to the model. For example, in that case, there is a camera. So the camera will have its own resolution and color format. The model will have a different resolution, a different color format, and a different data type. But the memory is limited. So there are, anyway, in the middle, operations like, resize, color conversion, cropping, and other things that must be executed in the most efficient way. So I enjoyed showing how to do it in, let's say, keeping in mind the memory constraint. Chapter 7 is the other project I enjoyed because that is on a virtual platform. The goal was to implement CIFAR 10 on a device which is roughly 10 years old, more or less, or 5 years old, more or less. Because the goal was to demonstrate that actually TinyML could run also on devices with important memory constraints like the one I used in the book. In particular, in that case, CIFAR 10 is running on the Cortex-M3 with only 64 kilobytes of RAM. So very tiny, I would say. It was fun to try to squeeze the model to execute the CIFAR 10 on that device.
I see. Those are great examples. And yeah, it's all around the constraint, the constraintment of the devices, not only power, but you said some limited CPU, I guess, if you're running on a Cortex-M, because that's basically sort of like the lightest processor that ARM makes, correct?
Yes, I mean, constraints is an important keyword here because constraints in terms of computational capabilities, constraints in terms of memory, and constraint in terms of power consumption. So this is TinyML. So you need to know your device at best. But at the same time, I'd say also the device needs to know machine learning if we want to build hardware in the most efficient way for machine learning. And that is the future. So the future, of course, will look close to ML to develop solutions that are friendly from a power consumption to these kind of workloads as well. But yes, that is also the work I do at ARM. So I work on performance optimization. And every time I say about performance, you mean, well, performance is speed of computation. Well, this is part of the problem. Performance is a lot of things. It's also power consumption, is also memory. And so we want to execute in a most efficient way in terms of latency, memory, and power consumption.
It's sort of the term TinyML is still kind of new, right? And it's kind of in its infancy. I went to the TinyML Summit, and I think it's only maybe in its 4th or 5th year or so, right? It's kind of still a new term that's evolving and morphing in the industry. Is that correct?
The TinyML word, yes, is pretty new. And the TinyML Foundation, actually, if people are not in the meta group, I recommend to join us because it is a free meta group where they can learn more about the TinyML initiatives. Actually, TinyML, the word is pretty new, but ML on these devices, well, already outside uni, I heard about it. The thing is, now it is easy to do it for everyone. And that is the big difference from, let's say, 5-6 years ago. Because if we look around us, I'm pretty sure we have, on a smartphone, we have activity recognition or handwriting recognition as well. So there are already applications powered by TinyML. But before it was difficult to do, or you had to be an expert. Now we have the tools, the softwares, and it's much easier.
Yeah, like I guess the go-to example that I always use is just consider wake words, whether it be OK Google or Hey Siri or whatever it is. Those were on cell phones, and there's essentially a special chip that listens for that word, and it needs to be very, very low power, right?
Absolutely. And that is an important use case. Actually, when we talk about TinyML, we usually refer to this use case, keyword spotting. So it's a new kind of interrupt for the hardware, right? So something you want to, you start when you only hear, for instance, this special keyword. And as you said, you need to run it on a processor that is efficient from a power consumption perspective because it runs continuously in background. So that is an important, although we are talking about a use case on a smartphone, well, TinyML can exist also on the smartphones because it can be part of that to trigger more power-hungry applications.
Yeah. And I think there's another thing that I've kind of been watching and reading. The other advantage to sort of TinyML is there's no connectivity needed to maybe a cloud service, for example. Inherently, maybe that would provide us additional security, right? You're not actually having to ship data. Do you see some of those benefits as well? If something can be autonomous and just sort of running on its own, figuring things out without actually having to be connected to the cloud or sending any data?
Yes. When I talk to my students, for instance, talking about TinyML, I usually start from why TinyML and not from what TinyML. Because in terms of why TinyML, well, we want to bring intelligence to object around us, but with a focus on power consumption, as we mentioned earlier, and focus also on data privacy and cost. Power consumption, we talk a lot about sustainability, so this is an important aspect to consider, but also data privacy, which means that we want to unlock smart applications without necessarily using an internet connection or sending data to the cloud. There are different reasons, but data privacy is one of these for sure. And I can give you an example. I mean, if we talk about a toy, a smart toy to learn vocabulary, to learn new words, well, actually, I prefer probably having a toy that doesn't require any internet connection just to avoid the question, where do the data will be sent? I mean, will be sent to the cloud? Probably I prefer a toy that does not require any internet connection or any setup, that it works without that. This is another thing. I mean, we want something that we can build with a small budget. And that is the reason we talk a lot about microcontrollers, for instance, because are everywhere, inexpensive, I mean, really popular. And so when we talk about TinyML, we talk definitely at the moment, particularly about microcontrollers. But it's not just microcontroller, but microcontroller is an important target platform for TinyML.
Absolutely. I was just kind of like taking a look more at the ML group, the TinyML group that you founded, or co-founded, I guess, in the UK. And you guys have events happening like pretty much every week.
Well, we try to have meetup group, let's say every week, every month or two. So we try to engage with the people every week, or we try at least. But yes, some of the activities have been every month or every 2 months. We are doing also activities in person in Cambridge, which is something new because when I founded the TinyML UK group, well, it was in the middle of pandemic. So we couldn't actually do anything in person. And now it's much better. Also, there is a Raspberry Pi here in Cambridge, so we could organize events in the store as well. So it was pretty fun, but that is pretty good now.
I'll be sure to put, a link off to the group. But yeah, I mean, it looks like there's a lot of interesting talks going on, some online events. I've actually attended, I think, one of the ones a couple of weeks ago. And I think I found out about this group from being at the TinyML Summit. And I think one of the co-organizers, Olga, was a name that I recognized. And so kind of followed her on Meetup and I'm one of the members of your 400 and I think 402 members, I guess, on this public group today. So that's great.
Well, definitely we need Olga. Without her, we couldn't do anything actually with her support. So on our side, we try to propose interesting presentations, not just theoretical presentations, but also hands-on sessions, for example. But yes, without Olga, it would be really, really difficult, honestly.
For sure. Well, where do you see the word TinyML going in the future? I mean, I'm a guy who kind of cut my teeth on Internet of Things. I've been doing IoT for probably more than a decade now. Although it wasn't called IoT back then, right? It wasn't really until maybe 2014 or so that the term IoT sort of came into existence and everybody was using it everywhere. But I always sort of thought that it was kind of going to fade away because everything is going to be connected to the internet. There's not going to be anything special about it. How do you feel about the word TinyML? You think that's going to eventually sort of fade away because we're just going to sort of expect these things are going to be smart? And
that's an interesting question. So I need to say that probably in this field, I don't see a single killer application because when we talk about machine learning, probably we think about what is the killer application? Well, for TinyML, probably there isn't, but different scenarios where we can bring definitely the intelligence on these devices. And I like to quote actually Alan Hollister from Raspberry Pi. I had a panel session with him 3 weeks ago, actually. He was saying, well, I expect TinyML in the short to longer term to be the layer on top of the sensors to bring the smartness in the less intrusive way. And that is what I expect also in the future. I expect TinyML to be the default way to bring the intelligence, to help engineers to develop smart applications without necessarily require internet connection. That is also what I expect. So to see the object around us more smart, or let's say to make AI ubiquitous, to use, but for good. And for good, but this is my hope, is to make definitely positive contribution to the sustainable goals of the United Nations. That is what I like to see.
Awesome. Those are lofty goals, but no, I think it's totally possible. And it's, again, technology can be used for good or for bad in any sort of way, but I'm always a fan for using it for good. And how do you see, this is a question I do like to ask people, and maybe it's a little bit off script, but like, how do you see these sort of smart objects maybe changing the way that we work? And maybe it's not even work. Maybe it's just how we recreate or how we go about our lives. Like, what are some examples or things that you could hope, you mentioned about, the United Nations and probably conserving energy or whatever it would be under those goals, I guess. What do you have any other thoughts around how you see this changing in the next decade?
I hope that TinyML, for instance, can help to have more sustainable farming. For example, I had chat with people that are in Africa where the use cases are simple, but pretty challenging from different point of view because, well, internet connection is something that probably is not there and is not really easy to access, let's say. But at the same time, you want to have a smart farming to improve the efficiency of your farming and avoid wasting resources at the same time. So I hope this technology actually can land there. Another challenge that I heard from them was about the server, because we talk about, you need an IoT infrastructure. Definitely you need a server, but a server could be your smartphone actually. Smartphones are actually now are really, really powerful. And so I really hope that we can unlock something like that in this environment where TinyML can help to bring the smartness to these devices, improve the efficiency, and maybe the smartphone can do the extra bit to actually build a more autonomous and more efficient solution for them.
It's awesome. Yeah. And just think of the number of smartphones that are essentially thrown away each year or that go into the recycle bin that are actually very, very capable devices still, right? People get a new one and they feel like they have to have the latest and greatest when actually there's a lot of hardware still left in these devices that could run for many, many years.
Yeah. The other thing probably I like is, TinyML doesn't cost a fortune. So if I consider microcontroller, with a few dollars, I can have a computer in my hand with, definitely it's not that powerful, but I can learn a lot of things. So probably TinyML and these devices can also help to learn more about electronic engineering in regions where, for instance, expensive devices are not really easy to get. So that is the other reason I like TinyML, because we can learn at the same time with microcontrollers very interesting stuff about electronics as well with a small budget.
Yeah, for sure. And it's kind of accessible to everybody. You don't need a lot of money in order to actually make this happen. I feel that way with IoT, in a lot of ways. The fact that the Raspberry Pi Zero came out and it was like, $5 or $10 makes it pretty accessible to just about any person in the world, potentially, to be able to just start playing with things, right? A lot of the stuff just comes out of experimentation, just allowing people that are younger, just coming out of school, to get their hands on some of these things. That kind of leads to my next question, I guess, is like, if somebody is coming out of school, I do like to ask this of some of the people that are guests on there, like, how would you advise them, looking back on your career, as someone's working through, are there classes that they take? I mean, obviously, we'll talk a little bit more about your book here at the end, but how do people sort of immerse themselves or get themselves into the space if they're interested in TinyML?
Okay, so be curious for sure is the key here. Be curious not just about machine learning, but also about embedded programming. This is a field where there is an intersection between these words. So if people after uni or during uni are interested in developing TinyML applications, well, definitely they should be curious about machine learning, but also about embedded programming. And here, my recommendation is not just about how to make it working, but also about why and how, why it works in that way. Because if we always ask ourselves why, well, probably we can have a better understanding of how this complex world works. Because definitely you can follow the recipes in the book to develop your TinyML application. But the why question should be always in our head to understand better and unlock other use cases that are probably not reported in the book.
I love it. Yeah. Yeah. And oftentimes what I'll have students do, or even myself, is maybe I'll work through an exercise, but then I'll say, well, what happens if I tweak this, right? So those exercises can be a starting point, but then the world's infinite. You can start, pulling in, well, what about if I pull data in from here? Or what about if I change this parameter in my model? And you can just start tweaking things and then starting to learn, oh, this is what happens, when I do this. And then bring it back, as you said, sort of like the why. We shouldn't just be building technology for the sake of building technology. It's maybe like, well, why are we doing what we're doing?
Regarding the book is it's a question-based book, because there are questions also in the book, for example, and some of the questions actually have been asked to me at uni directly by students. And one of these questions was, well, why do we have the program memory and data memory on chip for microcontrollers? That was an interesting question. And the answer was, well, we want to make a power efficient device. That is the reason. Primarily, everything which is outside the chip is going to cost us power. So if we put everything on chip, it's definitely more power efficient. But of course, it's not infinite, the silicon that we have for building our chip. So it's going to be small for sure.
Interesting. Yeah. There's trade-offs, right? Whenever you answer why, it's because of this, but you're also sacrificing, well, likely this, you need to make a decision. When it comes to actually writing a book, that is something that I shared with you, and I've shared with my listeners too as well. It's like, it's kind of a bucket list item for me. I really would like to have the opportunity to spend the time to write a book. And so while I have you on the show, because you're one of the few people I think that I've talked with that is a published author, could you walk me through, or I guess us through, the process, right? You had a reason as to why you maybe wanted to do this book, but then, there's a long path between having an idea and a reason to build a book to actually publishing it. So what were some of the highlights along the way? Maybe there were some lowlights, but what was the sort of path of you to get you from A to B?
Quite a lot of lowlights.
Okay. That's what I've heard.
I told you the motivation, but definitely from the motivation to the end of the book, there was an endless journey, endless nights, I would say. So for me, it was the first book, and Pact, the publisher, offered me the opportunity to write a book. What I learned definitely is, well, you can have the better story in your head, but you need to have a plan to deliver, and you need to be precise with the schedule. So that is one thing. With this, because definitely having a good outline at the beginning can help to shape the story, and that helped me. However, the outline doesn't solve everything, because I believe the most challenging months for me were the first 3 months, where I had to write the first 3 chapters. And I didn't know for instance, the tone to use, or how I wanted to shape the recipes presented in the book. So I don't know how many times I changed my ideas. Okay. But I can tell you that after 3 months and discussing with the publisher definitely helped me. So tip here, talking to other people can help, because it's true that you are alone probably during the writing phase, but people can help you to spot something that you cannot see, because you want just to write the book. And other people actually, which have probably a more open mind at that moment, can help you to say, well, probably if you change the tone here, or if you write this in a different way, can help you to explain the concept clearly. Definitely there were other challenges, because I had to write a book during the night, so endless nights, as I said, but it was at the end an interesting journey. I really enjoyed it, honestly. And if you ask me why I enjoy it, because I learned quite a lot from the TinyML community, because definitely a lot from what I learned at home, but also what I learned from the other TinyML smart people around the world. So I need to say thanks to them
Yeah, it takes a community, it takes a village to sort of build your knowledge base. And it sounds like you're a lifelong learner, I guess, if I could sum it up. You really enjoy the whole process of learning. And through this book, you learned a lot.
Yes, yeah, definitely. I learned a lot. I learned about new tools that I knew, for instance, but I couldn't have time for it before the book playing with these tools. Actually, the book gave me the opportunity to experiment more on these tools. I can give, for instance, Agent Pulse. Agent Pulse, I knew about the tool, but the book was the opportunity to learn more about it and also sharing feedback to them. But it was a very interesting learning journey.
That's one of the things that I found, if I have to teach a class or I have to do a presentation on something, then it really forces you to become kind of master the subject in a lot of ways. What was the timeline of you to write the entire book? Like how many months do you think it took you?
Okay, so for writing the book, it took me from end of May, let's say beginning of June and end of December. That was the time scale. And if I, let's say, managed to complete almost on time, because actually I was out of schedule already, it was because other people helped me to. So it was a journey where other people actually helped me to go in specific directions. So and see the things in a different way. And I think this helps a lot when you write a book. Sharing your concerns with other people is quite important.
Yeah, who did the review of the book? You said you got feedback and input. Were these technology people? Or were these people that have done TinyML, or would you just give it to your grandparents who don't know anything about technology or anything like that? Who did you sort of like pull in to do some of the reviews of the drafts?
Okay, so about the technical stuff, for sure, there was Alessandro Grande from Agent Pulse who helped me a lot, giving suggestions. He reviewed some of the chapters, but also my wife. Not from a technical perspective, but because I wanted to write a book that it was understandable. So I was looking for someone with no technical background, and she was perfect because she knew a bit of machine learning, but she wasn't aware of TinyML, and actually gave me some inputs saying, well, I'm not sure this is correct or this can be understood correct properly. So these are the two people for sure that helped me.
That's great. That is great to get, sort of two diametrically opposed, perspectives. You're going to sort of be able to pull the best from both worlds. So I think that's great. That's great, Gian. It's a great story. Before we sort of close out here, I guess, what are some of the easiest ways for people to get a hold of you? Do they just find you on LinkedIn or Twitter? What's your best social
LinkedIn is the best way. LinkedIn is definitely the best place. So I use also Twitter, but I recommend you add me on LinkedIn, definitely.
Perfect. Okay, for sure. Yeah, and we'll put links to you on LinkedIn in the meeting notes as well. Is there any other topics or any other things that you wanted to share during the conversation that I maybe overlooked?
Well, I think I will share with you some links that may be beneficial for the audience of this podcast, some resources as well. So in case someone is interested to know more about TinyML.
Yeah, sounds good. And I do know, it's tinyml.org, which means it is a nonprofit, right? It's sort of a open community, I guess, right?
Yes, the TinyML Foundation is a no-profit organization with the aim to share knowledge about TinyML worldwide. In different locations worldwide, there are the TinyML meetups group, one in UK, in US, there are other meetup groups in Italy. And definitely, if there is no meetup group in your country, you can request the TinyML Foundation to create one. And maybe you can be one of the founders of in the country. So, and you can start promoting activities. So it's an interesting place to be right now, because the things you can learn are not just from things on how to do things, but also learn cutting edge technologies or other research areas that are expanding and evolving in TinyML.
Yeah, perfect. Sounds good. And in fact, I highly encourage people to take a look. The applied AI community is really around applications of artificial intelligence, and TinyML hits that nail right on, because you're applying machine learning to a real world use case. And it's actually something you can physically sort of feel and touch, I feel. So I love what the TinyML community is doing. I'm attending a lot of these meetings and reaching out to people that are speaking at these events. And then I'll be having more and more TinyML thought leaders and people that are doing interesting stuff in the TinyML community, both at our Applied AI meetups that happen the first Thursday of the month, but also on these podcasts that we publish every week. So I think it's awesome. Thank you, John, for the work that you do, both in creating this book, because I know it was probably a labor of love, a lot of blood, sweat, and tears, and a lot of time going into this. But at the end, you should be very proud of what you have created here. I purchased the book, like I said, I love it. I think it's great. And I plan to actually pull some of these examples into the class that I'm teaching. And I'll recommend everyone to go out and pick up a copy. But yeah, just want to say thank you for all you're doing for the community. And I think it's great. We have some really exciting times ahead for the TinyML community.
Thanks a lot, Justin. And I need to say the same thing for your community, because it's actually, I was listening to some of the podcasts and I really, really interested. So keep it up.
Great. Thank you. We'll be in touch. We'll talk again soon. Thanks.
For sure. Thanks a lot for inviting me.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.